best way to think of artificial intelligence is a system that operates without an explicit set of rules somebody has told it to do. So it's not a programmer saying, hey, if X, do Y. It's a system that learns by reading data and reading itself and its system, and it learns what to do. Okay, that's what I'll call AI. Most people, when you hear at a cocktail party, when you hear AI, most people think of this, which in the industry we call artificial general intelligence. The idea of this type of AI is a computer that can think like us. Think of it as a computerized version of our brain. We are a long, long way from having artificial general intelligence. Depends on which expert you listen to. Between 7 and 70 years seems to be the guess, right? No one can really agree. But as you'll see in a moment, and as I mentioned, a lot of some big technology firms are struggling with these more narrower solutions. We're quite a ways away from the bigger version. Machine learning. So machine learning as a term means, as I mentioned before, if you're not going to give the system an explicit set of instructions on what to do, it has to learn what to do. And that term is called machine learning. And typically it means ingesting data, and as a result of ingesting data, it's learning what to do. A neural network, which I'll talk a little bit more about in a minute, is actually a platform or technology solution type that a lot of technologists use for AI work. And what it does is it's basically replicating how the brain works on a computer system. You know, when researchers tried to figure out, well, how are we going to get computers to think, some smart person said, well, why don't we get it to try to operate like our brains do? And I'm going to talk a little bit about that in a minute. Computer vision is a term which has to do with the ability of a system to look at a picture or video, a bunch of pictures, and identify things in them. Right? I'm going to show you some examples of that as well. And then finally, structured and unstructured learning. So when the machine is going to learn how to do something, there are two ways it can learn. One is in a very structured environment where you're feeding it data and you're telling it, hey, if you did something right, this is what it looks like. Whereas unstructured data is more like these video game examples where the system has to learn what's right as well as what to do. So this is where I'm going to talk about how systems learn, how an AI systems learn. And once we do this, I'm hopeful that everyone in the room goes, I get it, and I can think of at least 3 things that we could use this for. So let's assume that we were going to create a system to identify a cat. So these dots on this screen represent what is a pretty standard representation of a neural network. And again, stay with me. I know it's a little technical. Just think about the cats. So if you take data in, and you say, the output is, I want to know if this is a cat. You've got some sort of processing in the middle, right? Just think of that screen as like that. So you're taking data in. In this case, our data in is going to be a picture. And then the output is going to be, is this a cat or not? And so you give it a picture, and the system says, 68% likelihood that's a cat. And you're like, no, that's not a cat. That's a dog. So you tell the system, no, you didn't quite get that one right. You thought it was a cat, it was actually a dog. Now you see those little arrows? So what the system does, what machine learning does, and the way neural networks does, is it says, hey, I'm going to use some cool calculus and math, and I'm going to go update the weights of all those connections in the back, and we're going to try it again. I think the reason we thought that was a dog were for these reasons. I'm going to make some adjustments. Let's try it again. So now we feed it another picture, and it says, OK, I think this is a cat. Well, you barely think it's a cat. You get a 58% probability of a cat, and that's pretty obviously a cat. So let's try it again. So now you can see my little blue arrow. We make another adjustment. Literally, when you think of machine learning and artificial intelligence, the demonstration or the screens that I just put up is how it works. It takes data in, it gets a result, and it says, hey, was my result right? If it was, if it wasn't, either way, it adjusts the weights and all the little knobs and twisties along the way to try to make it better. That's it. That's how neural networks work. Okay? And then not only do we have to send it a bunch of different animals, we also have to send it, in this case, millions of copies of what pictures of cats look like. Because if you think about it, all of those are cats, and none of them to a computer system looks the same. So you build this system, you feed it tons and tons of data, and now the system is trained. The system is trained. We say, OK, you know how to predict a cat. So then when we give it a picture, it should be able to accurately predict whether or not we have a cat. So when it comes to AI and machine learning projects, there's two phases. You train your model. You train to make this neural network really good at predicting what you want it to predict. And then you run it. So if you think about the restaurant world, and let's say you're going to you want to predict upsells. Let's go back to the upsells example. You're going to train it on all these different orders that come through the system. And then you're going to say, OK, now start doing it. And we're going to see how many people click on the upsells you offered it, right? That's going to be how we run it.